All right, there's one last example that relates powers and exponents a little bit before I move into the next chunk, which is dealing with order of operations. So in this expression, we just need to evaluate it, find the value of it. We've got 3 to the 0 power, minus 3 to the 1, plus 3 to the second power. So I want to give a little bit of insight into some exponent sorts of things. So if we have 3 to the second power, really what that means is it's equal to 3 times itself twice. Because of that exponent of 2. That did it right, very well. Okay. So you can kind of treat it like that. Now, if you had, 3 to the third, that would mean 3 times of 3 times itself. Lots of 3's there. So really what that means is if we had to figure out what 3 to the 1 is, that's just going to be 1 single 3 that doesn't times with anything else, right? So basically anything to the 1 power is just going to be itself, right? So if we were to establish what 3 to the 0 power is, it needs to follow this same sort of pattern we're seeing in that as I move to the right each time in this pattern, we're always multiplying by an additional 3 because you're just increasing that exponent by 1 each time. So to really follow this pattern, then what that means is that 3 to the 0, well, think about what that would need to equal if this right here is 3 and this is 9 because it's 3 times 3 and this is 27, then by multiplying by 3 each time, this actually needs to be the number 1, right? Because 1 can times by 3 to equal 3. So you might think, oh, because it's the 0, maybe it should equal 0 instead, but then 0 times 3 doesn't equal 3, right? So what that tells us is that when we have an exponent of 0 on a number, it's always going to equal 1. It's always going to equal 1. There's an exception to that, and that's if you had 0 and then to the 0 power. We'll maybe talk about that at a different point in time because no one really has a concrete side to take on that issue. We'll debate that at a different point. So don't worry about that. Just think about anything to the 0 is just always going to be 1. So what that means then is now we've got basically just 1, because that's 3 to the 0, minus, and anything to the first power is going to be the same number, and then 3 squared is 9. Now we're going to talk about this in a little bit, is that if you've got a series of adding and subtracting, you have to go from left to right as you perform these operations, because if you did this wrong, there we go. Okay, so if you did this the wrong way would be to do 3 plus 9 first, and then you change it into 1 minus 11, and then 1 minus 11 would be negative 10. But it turns out that negative 10 is the wrong answer. The correct way would be to go from left to right, so to do 1 minus 3, which is negative 2, and then negative 2 plus 9, which is 7, and that's the correct answer. Because otherwise it'd be weird if you got two different answers, right? Like negative 10 as an answer and 7. So we make sure that we establish rules to make sure that we only get one answer, okay? And so the left to right rule is really relevant there. All right, so order of operations, something you're very familiar with here. Just kind of a good refresher. Hopefully it gives you a little bit of new insights and some things here. So order of operations is probably commonly known as PEMDAS. Please excuse my dear Aunt Sally. I will tend to typically go with this sort of acronym though. GEMDAS instead, and I put M and D on the same level and A and S on the next level. So what the G stands for is it stands for grouping symbols. There we go. Grouping symbols. So these are things like, for example, these symbols, which are parentheses, which are going to group numbers or quantities together. We might also have these square sorts of things. We call these brackets that might group stuff together. As we explore throughout algebra, if you've got stuff completely contained inside of a radical symbol, we might need to think about that. If you've got stuff inside of an absolute value bar, if you've got like a fraction where you've got a bunch of stuff on top, then you've got to evaluate all of that stuff. And then you've got stuff on bottom. You got to evaluate all that stuff first before you divide everything. So there's lots of different sorts of grouping symbols. That gives us a little bit of an idea of some of them. So it's not just parentheses that we need to think about first when we're evaluating expressions. We have to think about all the different types of grouping symbols we have. And then the E is, then we would evaluate any sort of exponents in our expression next in terms of performing operations and carrying them out. And then M and D stands for multiplying and dividing. But the important point right there, so here's I have to go from left to right. If we've got a series of multiplying and dividing, it's not that because the M comes before the D that multiplying should come before dividing. That's not true. We have to go from left to right, no matter what order of multiplying and dividing we have. And the same thing for adding and subtracting as well, is that no matter what sort of combination of adding and subtracting we all have in a row, we just have to go from the left to the right in carrying out that series of adding and subtracting. So just to kind of show you in an example here how that all kind of goes out. So we're going to evaluate this expression, find the value of it. So to do so, you should always follow GEMDAS. So the first thing you should think about here is you should think about, do I have any grouping symbols that I need to worry about? And you do. The grouping symbols that come into play here are the parentheses. So let me use some color here. How about? So you got the parentheses here. So what grouping means is like everything inside of the grouping symbol you need to clean up. So there could be a lot of wrong things that people could do right here, a lot of wrong things that could go on here. Having some issues with the writing going on here. Let's try that. Okay. So a lot of wrong things that could go on here is like to maybe multiply the 4. You can't distribute there when you've got an exponentiated expression, and the 3, we'll talk about all that at a different point. So just understand that grouping symbol comes first. So we're only focusing on this stuff inside, nothing outside of it. So the 4, the 3, the 10 have nothing to do with anything that we should do first. So we just need to take -1 minus 2. And -1 minus 2 is -3. And that's the only thing we're going to change. So we're going to leave everything else the same. Okay. And so we took care of grouping symbols. Now, I know there's parentheses right there, but that's really just to indicate and signify that that -3 is being raised to the 3rd, right? Okay, so the next thing in order of operations is to do with any exponents. And so that's the only thing we want to worry about is the cubing, the 3rd power, and it's only cubing the -3. So we're really only worried about this part. So really what that means is it means -3 times -3, that's +9. And +9 times -3 is -27. So that's the only thing we're going to change right there. And then we have the -4 times in there and the 10 minus that. So another thing that could have gone wrong that might happen is sometimes you might think, oh, 10 minus 4 is 6. But you can't do that yet because there's a subtracting there, and we haven't gotten to subtracting in GEMDAS yet. So we can't do that, right? Because at this point, you have subtracting there, but then you have multiplying there. So we're going to have to do the multiplying next, right? So multiply, divide, and the multiplying and dividing is really happening with the 4 and the -27 there, right? So because you do have a subtracting of 4 there, like you can multiply the negative, the reason why we can kind of think of that as is because this is really 10 plus -4 times -27. What I did right there is I took a subtracting and I made it adding the opposite, right? Because that's the definition of subtraction. So that makes it very apparent that, okay, yeah, it is like -4 times -27. So when you do a negative times a negative, you get a positive, and you would end up getting the number 108, and then 10 plus 108, and then at that point, then you could finish off with any adding and subtracting, which of course is what we have right here. You have adding, so you get a final answer of 118. Okay, so that just shows you an example where we use all of the different elements, the steps of GEMDAS in evaluating expressions. Okay, of course, the more examples and different sorts of scenarios we run into and that we practice, the better that we're going to get at with this. So just a few short examples that I just want to highlight here. So in evaluating this first expression right here, all the operations you have are just subtracting and adding. Just the biggest emphasis point is just go from left to right. Do not do 5 plus 10 first, because that would like go from the right to the left and break the rule. So you got to make sure you do this part first. Do 30 minus 5. Okay, and then you can do 25 plus 10. So that would be the correct answer and the only correct answer, okay? All right, with the next expression here, you do have lots of stuff going on. So think about any sort of grouping symbols you would have first in terms of GEMDAS. You actually do have a grouping symbol because this fraction bar is like a grouping symbol. What that really means is you got to figure out everything on the top first and then everything on the bottom next after that. So I really want to focus on this 9 plus 2 times 3, and within that you've got a plus operation and a times operation. Because of GEMDAS, you have to do the multiplying first before you do the adding. So you have to do the 2 times 3 first, which is 6, and then you can add 9 to that, which would be 15. So you're going to get 15 over 3 there, and then 60 divided by 2 times 15 over 3, right? Now, it's kind of written weird because you got some horizontal stuff here and some vertical stuff here. So a way we could write this problem differently is to just go like this, and that's the same thing, right? So now it's only just dividing and multiplying. There's no more adding or subtracting going on, so it's just kind of the MD part of GEMDAS. So you just got to go from left to right. So you just got to do 60 divided by 2 first, which is 30, and then from there, then you got to do this part next. 30 times 15, that's a little bit larger, I guess. That's 450, yeah, okay. And then 450 divided by 3, and that's going to give you a final answer there of 150. Okay, so a little bit of a different sort of thing to encounter there. This one's got a divide, a minus, and a times, right? So there's no grouping symbols, there's no exponents, just multiplying and dividing is going to happen here with dividing, and then multiplying there. So you got to figure out those two separate chunks, and then we'll subtract at the end. So the first part is 12 divided by 6, and the next part is 2 times 1, and then you can do 2 minus 2, which is equal to a final answer there of 0. All right, and then with this example here, just kind of want to highlight some parentheses and exponent stuff really for the most part. So you've kind of got this first little chunk of the expression you want to evaluate, and note that you've got parentheses inside of parentheses. So if you do ever have grouping symbols inside of grouping symbols, you got to start with on the inside and work your way out. So you got to work with the 1 plus 1 inside of the parentheses there, which is 2. And then you got 5 minus 2 in the parentheses. And notice there's that negative in front, which really means it's multiplied by negative 1. Yeah, so we've got that. And then let's go ahead and deal with what's going on there. Note that you cannot distribute the 3 there whenever you've got that quantity following it raised to an exponent. So you're going to have to use grouping symbols, the parentheses part of PEMDAS, to evaluate the negative 2 plus 6 part there first. So that's going to be 4, because that's negative 2 plus 6. Okay, so we've taken care of most of the grouping symbol stuff. There's just this part, which is 5 minus 2, which we can change to 3. Okay, so now we've taken care of all of the grouping symbol part of stuff. So the next part would be any exponent stuff we have going on, which we have going on right there with the 4 squared. So if you did 4 times 4, that would give you 16. So that becomes 3 times 16. And then from there, any multiplying or dividing, you have multiplying there. So because you've got a negative 3 and then a positive 16, it is like a negative times a positive, which would be 48, that's negative. And then you have that negative 3 minus 48. So when you subtract that all together, that gives you a final result there of negative 51.